Hello again, grade 9s. So in this part, this is lesson 1, part 2. We are going to go into what exactly weight is. It's going to be a very short video, and then I'm going to expect you to try and apply the formula to some problems. All right, so I want to make sure that you are on page 3 of your notes, and you are right above or just underneath where we went over what lift is. Remember, lift is a contact force, and remember it's involved in with air particles and actually helps the airplane lift into the air. All right. So I'm sure I've said this before, but I'm going to say it again. There's a little section right underneath lift with 3 little lines that you are going to write in these 3 things, these 3 characteristics of what a force can cause. Okay, and remember that the work that we are doing right now, it's got to do with the work of Isaac Newton. He discovered what gravity was, and he developed the laws of motion. 3 characteristical, 3 things that a force can cause is distortion. What is distortion, grade 9s? It is a change in shape, a change in motion, and a change in direction. So please write those 3 in, just in that little section right underneath lift. And then we'll go on to weight, and I will explain exactly how how gravitational acceleration is going to affect mass and therefore is going to equal to weight. So, grade 9, you will remember when we were discussing matter, what did I tell you? I told you that all matter has mass. Okay, and we measure mass. What do we measure mass in? We measure it in grams or kilograms or micrograms. There's different types of unit depending on how small or big that mass is. It's a physical quantity. Now, like I said before, there's a downward pull on the earth, and all the objects on earth are affected by this downward pull. On Earth, that downward pull is 9.8 meters per second. That is gravitational acceleration. That is the measurement of the downward pull on mass, on the object. So if we want to determine the weight of an object, we are going to have to take into account gravity, because gravity influences the weight. How do we do this? We look at our mass multiplied by our gravitational acceleration. Now remember what I said, on Earth it is 9.8. That doesn't mean that on other planets it might be higher or lower. The acceleration might be far larger or far quicker on Jupiter or Mars. You never know. There are different different gravitational accelerations depending on where you are. But for Earth, it's 9.8. So what am I going to do if I want to figure out the weight of an object? I'm going to take mass multiplied by gravitational acceleration. You will see at the bottom of your page 3, there's a little block. I want you to fill that block in. I want you to write in there Fg, which is gravitational force. And remember, we measure that in newtons, which is a big N. Is going to be equal to mass, which is, what is our SI unit? Kilograms, times gravitational acceleration. Okay, and that is meters per second. Okay, excuse me. There's also a little block at the bottom to show you how you would convert these quantities. And I think we did a little bit of this in SI units. We touched on this a little bit. So if I wanted to figure out the force, the weight, I'm going to take mass times 9.8. If I wanted to figure out the mass, I'm going to divide it by 9.8. And then we look at grams and kilograms. You guys already know this. You should be super comfortable with this. It's important to remember that weight is dependent on the mass of the object or the person and the gravitational acceleration. The two work together. Okay, so please fill that in, and then we'll carry on with the rest of the lesson. So at some stage, we are going to expect you guys to represent these forces, these contact or non-contact forces that are exerting on a certain object. And there are two ways to do this. You either do it with a circle or a box. However, we want you to use a circle. Do not use the box. So I want you to look at these objects here. Let's look at the first one. You've got an object in the middle that's drawn with a circle. Then you've got normal force, remember, perpendicular from the object. You've got applied force, and you have frictional force, and then gravity. They have actually given you the applied force and the frictional force. And you will see that they're both 50 newtons, which means that they are equal. They are equal. So this object, if this object is at rest, which if it is, say for example, I don't know, an object that is sitting on a desk or on the floor, this object is either going to keep moving at the same pace or it's going to stay at rest. In all probability, is probably at rest because the frictional force and the applied force are exactly the same. Exactly the same. The point I'm trying to get at here is when you draw this, I want you to draw the circle. And you're going to be expected to show me all the different types of forces that are at play. And depending on the example I give you, you'll be able to do this. I promise you, before you know it, you're going to be doing this with your eyes closed. The arrow or the line in the arrow represents the force. The length of the arrow shows the magnitude of force. So let's, for example, say that the frictional force was only 30 newtons. Then that frictional force arrow would be a lot shorter. It would not be as long as the 50 newtons. It would be shorter. So the longer the arrow, the greater the force. Okay. At the top of page 4, you will see that there's a few calculations. I'm going to do the first calculation with you. You're going to write this in, and then you're going to do the remainder of page 4 questions in your either in the rest of the lesson or as homework. The first question asks, what is the weight, not the mass, what is the weight of a fluffy lamb that has the weight, that has the mass? So it should not, guys, please take that word out. This should not, over here, this should not be weight, it should be mass. So please write mass in there for me, please. Okay? So what is the weight, that's a typo, I'm sorry. What is the weight of the fluffy lamb that has the mass of 12 kilograms? You're going to apply the weight formula, which is Fg equals mg. You're going to take 12, you're going to multiply it by 9.8 because we're here on Earth, and you're going to get 117.6 newtons. How many marks is something like this worth? 3 marks. You get a mark for formula, you get a mark for substitution, and you get a mark for the answer. Grade 9s, if you don't put the unit in, we minus a mark. So please write this in, and then I want you to look at the other examples we've got there, and I want you to try and finish it. Do all of those. There's only there's 4 questions, so you guys only have 3 to do. It's very, very easy. And in the next lesson, in lesson 2, we will go through the answers with you. Okay, so good luck, and I hope this is helping you. I hope you understand these concepts and that you are comfortable at this stage.